All right, so, before we get started, I want to kind of give you the rundown on how I structure the course. So I always will start with, what do you see? So your Canvas course, what is our syllabus? And then we'll move into what I already emailed you about, with the welcome slides, and then going into alkanes and combustion. I absolutely love it when my students work with me. I will be pausing a lot to ask you questions. I want to make sure that y'all are comfortable being okay with blurting things out. It's okay to be incorrect. It really is. When I was in your shoes, even when I was just petrified. I never spoke ever, because I just thought, okay, well, I'm probably the dumbest person in this class. I don't have an answer. I shouldn't say anything. That's not true, because sometimes if you just say what you think, you might be on the right track and we can build off of it. And you should never think like that, because if you are questioning something, someone else is also questioning something. So please don't hesitate to say something. I never want to be a professor that makes you feel bad about saying something. Let us start with this Canvas site. Move that over. Here's what you see on your end. I tried to make it as short and simple as possible. This is a hybrid class. We want to make it hybrid because we have students who physically cannot be on campus every single day of the week. If you are one of those students and you would prefer to learn this class online, you will have that option available to you. And if you miss for whatever reason, that's okay. I record these lectures and I will post them online, so you always have access to them. We don't have attendance, so I'm not monitoring you. I'm not, making sure you're here. Although I highly recommend it, because these classes, it might be like I'm taking a long time to get to the point, but the goal is to practice, practice, practice. In chemistry, you can't just, and this is my big failure when I was in shoes, I would try to read my textbook slides, read the textbook, and I'd go into an exam and I would fail it. Because chemistry is not memorization, chemistry is practice. And the goal would be in this class is to learn a concept and practice. So there's going to be some downtime in class where I ask questions online in person. And there's going to be some downtime where I actually give assignments in person, where you'll be given, work through things. The answers are always going to be provided for you. I'm not trying to force you where if you have to get the right answer, turn in, you get your points and you go. No, this is not going to be part of your grade, but by us practicing, it's going to make you doing your homeworks and your exams. And I do have a couple quizzes. Those are going to be easier in the long run. So we're going to practice. So work with me. If we have calculators, have your calculator out with you, have your notes with you, and then work with me when we have that downtime. Don't just try to get the answer, because the answer is not going to help you. I'll give you the answer. It'll happen. But it's how you get the answer that's most important. Also, I kind of go off into directions, and I'm sorry about that. I'll do my best to stay on track. So course calendar. I do want to point out that the Canvas does have a calendar over here. This is not the same thing. If you go click on the Canvas calendar right here, I don't have the same thing that I have in this course calendar. This course calendar is just a page I made in Canvas that I kind of throw all my information in. Whereas at the course calendar, it's kind of like you're getting a bunch of emails and blah, blah, blah. I don't want to do that. So here is my goal for this semester. I might not hit everything. I will be making additions or editing as we go, but this is my game plan. The one thing that will not change are those exam dates. I'm not changing them. Those are set in stone. If I don't finish my material, then we don't cover it. But the exam's going to be there. That way, those of you who have jobs who absolutely need to set that date in stone, everything is available to you. So you can see today I did email you and said, read before class these sections. I actually went and read them myself. They're not too bad, not too long. But let's say this material using, I highly recommend, taking a view of what we're going to cover. Even if you don't feel like reading every single sentence, maybe skim it to get those, bolded words. What are they saying? Before you come in. And so I have that before every single class period. And then I have those goals. So unit 1, unit 2, unit 1's just a welcome. And then what are the topics? And then we just keep going. Our first exam is going to be June 13th. It's going to cover all of unit 1. I kind of took those chapters and I just put it in unit 1, 2, 3, exam 1, 2, and 3. And so exam one is gonna cover, I need to change this because this is not right. This is just gonna be review, so we don't have unit 1.8, so 1.1 through 1.7. And then, what I'm changing from your normal semesters. In your normal semesters, you would have homeworks and quizzes due at specific dates over those 15 weeks, but we don't have time for that. And everyone has jobs and things like that, so I'm just gonna make everything due before the exam. That can be very helpful to those who have very, very busy schedules, but that can be very hurtful for those who are procrastinators. So this class is all about practice. And so if you wait until the night before to do your homeworks and your quizzes, yes, it can help you, but you're probably going to be more panicked to get the right answer. And so you'll probably look at outside resources and then not care about what you're learning. So yes, it's there to help in case you do need to procrastinate. That's fine. It's there. It's unpenalized. You can do, not the quizzes, but the homeworks are, you can do them as many times as you want, but we want to get you to learn. So if there is leftover time in class, I'll probably pull up the homeworks and work through them together. But all of those homeworks are going to be due, which is not very many, maybe like four homeworks are going to be due, right when you come in for them. And the exams are in person. They are not offered online. So if you want to be in person for a lecture, that's optional, but the exams are not optional. They're, if you miss an exam, I'll go over the syllabus in a little bit, but like, it's okay if you miss an exam because we do have the ability to drop one, and have it replaced with your final, but you have to physically be here to take all of those exams. And that's 1, 2, 3, and the final. Unit 2 is very similar. There's only gonna be 6 units, and then our next exam, I wanted to do it before the holiday. That way you're not studying through the holiday, because I don't want to be making the exam through the holiday. So that'll be the 2nd of July, and then have a couple of days off. You'll have a holiday and then a great weekend, and we'll start unit 3. The 3rd exam is going to be the 28th, and then we're gonna have just a straight review for the final, and then you'll come in August 1st for that final. So this is a 2-month 10-week summer course, not a 5-week, so it's kind of spread out. Any questions on the calendar? Okay, I do need to make some changes just because I haven't created those modules yet, so I might be changing like the unit numbers, but this is going to be my game plan on the subjects. All right, let me go back to home. If you need to, come online for the Zoom meeting, I have all the information here. I mentioned I need to fix this because this is going to be changing when they give us our new assigned classroom. I'll email you when they do that. But this will be, you'll have access to this every single time we meet online, which is same thing as class meeting times. So Monday, Wednesday, Fridays from 12 p.m. to 1:40. The only exception are exam days. I do offer office hours. Just note that my office always has please knock when you can just come in whenever you want. But I'll definitely have set office hours, and they're usually an hour after we meet, with the exception of exam days. So you're welcome to come in my office hours online or in person. I don't care about either, wherever you feel most comfortable doing. But if you can't make that hour, let's say the lab or you have something else, you can come and just email me or just pop your head in. I'm usually going to be here the days we meet. So Monday, Wednesday, Friday, all day. So, yeah, just pop your head in if it says please knock. My office is Kim 215. So right now we are in Kim 133. That might change for in the future, but my office is 1 floor up. And if you go, through the chemistry building, it's just right past the stock room, Kim 215. All right, now I'm going to hit the syllabus and then we'll move on to our, these, let me just download it. Oh, now I can share. No. Guess I should just do the screen. Here is our syllabus. I just want to go over some main points. I talked about why study chemistry. Chemistry also just has a lot of real life applications. I'm biased because obviously it's my major, my PhD, but what I like most about it is that the versatility. I have friends who, with their chemistry background, were able to work in like the lab of a beer company and they got lots of free beer, which is great. I have friends who worked in cosmetic companies. And this isn't just working as a chemist, this is just working for the company with their chemistry knowledge and help them get them in. I have friends who've worked for the government, friends who like anything and everything. Your chemistry knowledge is going to be very helpful in your future careers, even if you don't have any in chemistry. So that's my bias. Chemistry is awesome, even if you don't want to be a chemist. These numbers are going to be off just because this is a spring syllabus and I made some edits. This is going to be different. Here's my email and then my office number, and then here's my office hours. And what we're going to try to learn is critical thinking, communication, our empirical and quantitative skills, and teamwork. I don't know what the online component will be enough to be able to do teamwork, but we'll try our best to get teamwork with just good communication. How to prep for this class. I'm a very like, I don't know, I guess because I'm older, but I like to have my lectures printed out so I can write all over it. But I love seeing the new technologies where you want to have it in front of you, you can write on it with your computers. That's fine. Everything is available to you under modules. I should have shown you that, but I'll go back and show you that. Under modules, you'll have all of your units, and if you click on them, it'll have those slides. So you can download them ahead of time. It also, if I go to modules, it has all of your worksheets. So I passed out a worksheet in person. If you are online and you want to go ahead and download that same worksheet, that is going to be under modules, unit 1.2. So it's an alkanes worksheet. We'll work on that at the end of class. I also have the key up. So like I said, the answers are always going to be available to you, but while we're in class, it's not about having the right answer and turning it in and getting a grade. It's about learning why is that the right answer. So everything's going to be available to you in under modules. So print that out, take notes while you're in class, especially when there's practice components and I stop class and say, work on it. That's when you want to definitely take notes. While we're doing math, I will probably stop and show you how I type things in the calculator. But also do your math with me. I'm human, I make mistakes, and I absolutely love being corrected. So if you're doing your math with me and I make a mistake, please tell me, because everyone makes mistakes in math, and it's about, trying to figure things out and make it on the right track. Usually my math mistakes triggers me to recognize, oh, okay, I made a mistake up here, let me fix it. So I'll teach you how to do that. Yeah, so yeah, and practice. Everything that we learn in lecture is going to your homework. Homework is going to be just more practice. And so if there's another kind of lecture, which I tend to talk very fast, it can be very annoying. I'm sorry. I need to slow it down. But sometimes we're going to be spending more time practicing than lecturing. And that's when we're going to, just not try. If you have things to do, like there's an emergency, yeah, go. You have these lectures, you have these notes. But for the most part, if you have the time, stay and work on it. If you have extra time, stay and work on the homework, especially because my office hours are always available to you, but my students who tend to be like the most successful are the ones who kind of take that office hour and pop their head in and say, hey, I messed this question up, can you help me? I understand not everyone has time for that, but even if you're just in the building with me, you can always pop your head in and say, hey, I messed up, where did I go wrong? Board in my office during office hours, because no one comes and visits me, so you're welcome. Even if you don't want to sit in my office, I have a little nook right outside. It's a great place to study. Participate in class. My goal is just to make you feel more comfortable just thinking about things and saying them out loud, even if you might or might not be right. I would never criticize, but our goal today is or in this class, is to just think about what is going on. And not memorization, not just memorization. Yeah, this is a more spring version of a syllabus, but summer is going to be more sparse. So we don't have exit tickets. We don't have deadlines for activities, just make quizzes and homeworks. After class, of course, review the notes and then do your homework as a review. So let's say we talk about today combustion and alkanes. while everything is like, you feel really good in your mind about what alkanes are, go ahead and do those homeworks that cover those questions. Because let's say you wait 2 weeks to do the homework, you might forget all that great stuff and you felt really good today. But if you're not thinking about it later, you might forget some of that knowledge and it might be more stressful for you. And so my advice is like, let's say questions on alkanes in the homework, I don't know that number, but it might be a little bit less stressful to hit those 5 out questions in the next 2 days than, add it on to the end of a giant list of homework at the very end. I will have quizzes. I haven't written the first one yet. I think I might do like 1 quiz a week. With the exception of exam weeks, just because I'm trying to think of the least stressful way to give you some quizzes. The quizzes are gonna be multiple, you have like 2 times to take it, so it's not gonna be like all or nothing. It is 10% of your grade, but like, my advice would be the first time you go through it, try it with no notes, study for it, try it with no notes. And then, figure out where you went wrong, where were you confused? And then the next time you take the quiz, obviously take it with your notes, do what you have to do, get the highest grade possible. But it's not do or die, it's gonna be, I think, 2 tries for the quizzes. Okay. Material, like I said, I'm more of a physical person, so I like to have a physical text. We have it online, we have the e-textbook through Achieve. Make sure that you get into Achieve soon. So I have that in a module, but you want to make sure that you can log into Achieve using your Booksmart program because you were given all the information. Don't pay for it separately if you have Booksmart. And link the Achieve site to Canvas. I think I have some like how to see a module in Canvas, but make sure that you can link Achieve to Canvas. That way, whenever you do your homework, it's populating in Canvas. Just note, it's not going to be immediate. Sometimes students will have 100, but their Canvas grade will say 80, but it's only been like 5 hours. So just 24 hours and then panic, and then I'll help you. Calculator. We don't do graphing calculators. I know when you're here in front of me, I'm not going to tell you, no, don't get graphing calculator. But for exams, we're going to be using these calculators or just a regular scientific. The reason why is when you get to Gen Chem 1, they are going to require these calculators. And if you are only comprehending a graphing calculator, it'll be kind of a big hit when you get to Gen Chem 1 and now you don't know how to use the features on the required calculators. So my goal would be like, we have calculators in stock. So if it's an exam and I say, no, you can't use your calculator, I'll bring extras, no worries. But there's always, the stockroom upstairs has extras where if you give them like an ID, they'll trade you. So if you ever want to like borrow one of theirs, you're welcome to. Yeah, these are just scientific calculators. I like the Texas Instruments, they're my favorites. Resources and expectations, here's what we worked out. I'll try to give you maybe like a quiz a week. I don't want to give you too many, but I think we're gonna drop your 2 lowest quizzes. That way, it's not gonna be hurt if you miss one. Especially if you miss 2, if there's emergency, like you miss them, good. Don't worry about it. Obviously get the notes from them, but not gonna hurt you. Homework, same concept, we'll drop your 2 lowest. Because we drop them on late work, even if it is like, I have an excused absence, we just say, don't stress about it. Don't let it worry you. Just move on to the next one. We will have 3 midterm exams on the 13th, the 2nd, and the 28th. What I will do on exam days is the first half of class will probably just be review for the exam, and then the exam will be short and sweet, 50 minutes. So it's not going to be like an hour and 40 minutes sitting in here. Not going to happen. I don't want it done. So it'll be a 50-minute exam, and then you're good when you're done. And then the final, I will say for these exams, if you miss for an unexcused reason, that's okay. We'll replace that exam with your final. It's not your fault. The final exam is the only one that cannot be missed. So you need to come in and do the final. I need to double check this time. No, it's at noon. But I'll let you know if I fix that. Okay, grading, homework, we already discussed all of that. Quizzes will be in Canvas, homework will be in Achieve, so just make sure that you link up Achieve in our Canvas site. Exams, yeah, no graphing calculators on the exams, but I'll have extras if you need them. Absent policy, there is no absence policy, but I highly recommend coming every single time if you can. We put this in because sometimes students get a little confused with the Canvas gradebook. As you turn things in, I'm uploading, doing everything in Canvas. But if Canvas doesn't have all your grades, it's not going to be accurate. So you'll see where you stand at that moment, but if it's missing 21% of your overall grade in a final exam, that means that like in reality, you're missing. So I kind of like pretend, but I didn't have really these LMSs when I was using until I hit grad school. But when I hit grad school and I had them, I was like, okay, my grade's a 50. What can I do to bring this up? When in reality, it was a little bit higher, a lot higher than that, but pretend you're not doing as you are. So when you go into the final, you're not like, I need a 70 or I need a 50, you know, you might need a little bit higher than that. So just be on top of that. It's heartbreaking when like a student thinks they have an A and then the final to a B, and it's just something I. Okay. Some advice from former students, just stay on top of things. I love summer classes because you're seeing it more often. In your normal semesters, it's not even your fault because you're not even seeing things every single day. You're seeing things every other day. You have 5 other classes you need to focus on. This is not a priority. It's very stressful. Seeing this more often, and you're seeing this maybe with maybe another class, but you're not seeing as many classes. So it's going to help you be more on top of things. So once again, do not wait until the last minute to get started. Use the time in class, use the time you have after class or in between classes to kind of get caught up. Start homework as early as possible. When I take classes now, I didn't do this when I was in undergrad. I was not a good student. Now, I go in class and then whatever homework we have, I do those questions within 48 hours, and then go to class and then do those homework questions. Go to class, do those homework questions. That way, when I hit exam time, I was able, this is recently, I was finally able to go to sleep by 10 p.m., which is when you have an exam the next day. So that really helped me to just review the day before and not have to think about homework. So, into you, come ask me questions, review, things like that. Look over the material before class and of course before the exams. If you have friends or, you know, even though in this class it's going to be mostly online, we're going to be split up. If you are interested in making study groups with people you see familiar faces, I highly recommend it. And then this is my biggest thing, practice. I'll be annoying how much I try to make you practice, but that's the best way to study. This is not a cramming class. Some students can, but majority of students don't learn like that, myself included. I cannot cram chemistry, I just can't. Too many times I've withdrawn because I tried cramming. So practice, practice, practice. And then of course, try your best to make every single class you can. These are advice from former students, not from me. I'm just agreeing with them. It is easy to forget online assignments and quizzes. Make sure you set calendar reminders if you're very forgetful. Just to fine print, things like that. So that's our syllabus. I will be editing it a little bit because of the changes in the classroom and the changes and other things. I'll try to take out the stuff about like exit tickets. I'll take that out. Let me come back. One more thing. By the way, I do schedule breaks. Our next break's not going to be until 12:50, but I give a 5-minute break halfway through because an hour and 40 minutes is too long to sit and focus. But yeah, you're coming up on a break. Okay, so periodic table of elements. I'm giving this table out to everyone in class, but if you are online or you just forget or lose your copy from your day, they're here. If you need to get into Achieve, here are some helpful ways to get into it. So here you go to log into Achieve, use your Booksmart information, and then follow the instructions on how to link it to Canvas. That way your gradebook is linked to you. And then here are our units. So if you click on everything, you'll see the PowerPoint that I planned on giving. They might have a little difference if it's like, you know, Dr. MJ Patterson versus me. Here is what I would love to get done today too. So I'll be a good goal. And then this will be here is the paper or the assignment activity we're doing at the end of today. Okay, if we don't finish it today, we can start it next class, but here is where you have that. And the answers are on the next one. So please don't look at it until we get there or until you're checking your answers, but you will always have access to them. Yeah, that's everything on Canvas. Any questions? I'm gonna switch over to my laptop. Yeah, thank you for that. You know what, I also had an error when I tried that. I'm calling them after class because I was trying to get your homework set up. So I'll call them. They do also have a number you can call or troubleshoot with. But if my links don't work, you're welcome to go straight to their website and try it from there. But that's not a you issue because I also right before class and I made a note when I got done today to go work on that. So thank you for pointing that out.
When I clicked on the last link on like the Union One, I guess it worked from there, but it didn't from the other, so. I was able to access the book from here.
Oh, yeah, that's my link. That's my little special link.
Yeah, the one that works, none of these,
Okay.
I'll say error, but that last one works.
Okay. So the last link on the Achieve module did work for one of us. So I'll work on the other links. I might delete them and redo them, but just be patient. I'll get them done later. Let me make this so y'all in class can actually have a good view. Is that big enough for y'all? Are the lights okay? Do you want me to dim them a lot more? I'll try to dim them. That's the best we can do, I guess. Okay. All right, let's get started on what I planned today. We have a 5-minute break scheduled at 12:50, and then when we come back, we'll just finish the rest of the class. I'm gonna do my best to talk slow. Don't hesitate to like say, I'm confused, or that was too fast. It's not a you problem, it's a me problem. I've been working on it for years. Especially because it's teaching this course. So I have some notes to help me, not because I don't know the material, but just to help slow me down. All right, welcome to 1320. I'm really excited to teach this course again, just because it's new and it's learning different things to help you get ready for Gen Chem 1 and beyond. So we're gonna learn a lot of really wonderful things. We're gonna hit on chemical literacy, math fluency, and problem solving. So as you get more and more comfortable with this, it's gonna be so much better for when you go hit Gen Chem 1 and Gen Chem 2 and beyond. Those students who might skip this might have a lot of struggle when they hit there. What am I trying to say? So a lot of students that will bypass this course sometimes do hit a little bit of a wall, and they might have to go back and teach themselves a lot when they hit Gen Chem 1. So with y'all are gonna have a big step up. So end goal for the summer is to have these things, and the purpose, head start for all future chemistry classes. Let's see. This is something I wasn't really thinking about until I hit graduate school. But there are 3 representations I want you to get more comfortable with when we think about chemistry. Macro, this is macro for macroscopic, micro for microscopic, and symbolic. Macroscopic is what we see on an eye level. So here on this slide is a lit match. It doesn't look like it's chemistry, but it is. It's combustion, which is where you have some type of fuel and you light it on fire and it has a reaction. So macroscopically, what do we see? Anyone tell me, what do you see when I light this flame? I'm not really looking for a correct answer here, just what do you see?
See like the colors in flame.
Yeah, if you, depending on what type of flame it is, but sometimes you'll have like a little bit of discoloration the closer you are to the middle versus the outer side. Does anyone know like the difference in temperature there? No? Hotter in the middle and a little bit less hot on the outside. That color difference kind of tells you that. But yeah, so macroscopically, this is a chemical reaction right here. And we see a lot of chemical reactions macroscopically every single day. I always kind of use like making sweet tea like that instead of water. You wouldn't think that's chemistry, but it is because sucrose or glucose are sugars and adding them to water, it's a chemical reaction. So I'm seeing, clumps of solid sugar dissolve into a liquid. That's chemistry. So it's macroscopically. Microscopically is when we go zoomed in very, very far. What is happening on a particle level? So in this top picture, I know it's not a perfect representation of what's happening when I light a match, but it shows atoms. And those atoms are microscopic, so particles. So if I was to take the chemicals that I took to light that match, that would be a microscopic representation of what's going on. Symbolic is this bottom right here. So symbolically, this is an example of what could be happening for a combustion. Obviously, when I'm lighting a flame, they probably put sulfur on the end of a piece of wood, light it. It's similar, but here is a symbolic and a different type of combustion reaction. So the letters, if you're a little rusty, the letters are elements from the periodic table of elements. And you take that chemical reaction and you put it in an elemental reaction. I think a lot of us kind of struggle because I think we're just forced in chemistry to kind of like do things exactly the way they are, but it's really fun to start thinking of them in these three different representations. So don't just be given a chemical equation, but think about it like, what does it look like, in general, what is happening in the particle size? So when you go into labs, macroscopic is going to be what you see in the labs. So observations, and what you do in the lab. Microscopic is going to be in particle level, so reiterate. And then symbolic is what I have below. So this would be a fuel. Does anyone know what O2 is? It's oxygen. It's not going to be like, I'm not putting the two out in front and thinking about it. It's just O2 is oxygen. So if I take a fuel and I combine it with oxygen, because with flames, you need oxygen, a reaction occurs. And does anyone know what CO2 is? Carbon dioxide and then H2O. Elements, or I can just write out letters. So symbolically, if I mix a fuel with oxygen, it'll explode and it'll produce carbon dioxide and water. So it's not gonna be wet. That water is in a steam. It's so hot, that flame is so hot, that water is a vapor. So you might not use water means I'm gonna be video. It's gas. Same with carbon dioxide. We are going to be getting into math. Today, we're not doing math, but in this class, we're going to be doing a lot of applied math. So I think up until this point, we've learned a lot of theoretical math, meaning that like, here's an equation. Why are we using why? In this class, it's all about applied. This goes back to what I was mentioning, why I love chemistry, because even if I've never looked at it before, can I apply it? And using my stuff I've learned 10 years ago, most of the time, I can always figure out my way to the end. And that's what applied math is, taking your fundamentals and being able to, figure out a nice little puzzle. So we're going to be doing math with letters. We're going to be doing math with numbers as we kind of refigure things out. And we're going to be doing math with calculators, with and without calculators. I have a very bad habit. The further on in math I got, the more I relied on my calculator, even though now like I sometimes will type in what's 8 + 16. I can't do it. But it's important to also be able to use math without calculators because you can kind of fix your mistakes easily. And what I mean by that is, let's say let's say I'm weighing something in grams. And for some reason I did some math with it and like I'm getting like 1,000 or a really, really big number. It doesn't make sense because maybe I'm weighing something like right here. So sometimes not having the math or the calculator with you kind of finds those mistakes. This is going to be towards the end of Unit 1. We're going to be using a system called VERSE. Equation that you're not going to see. for a little bit. PV equals nRT. This is the ideal gas law equation, which you won't really need very, very well or memorized until you hit Gen Chem 1. But I'm putting it up here because this is a math equation you will see. The variables are what those letters represent. So P is pressure. You don't have to memorize this now. This is just me showing you an example. V is volume. N is moles. R is the ideal gas law constant, and T is temperature. So we're not using this today or not until a while. But the variables are those letters. So if I was to give you the numbers, pressure is 5, what are you gonna do with it? So P, or the letters are gonna be your variables. The equation itself is what's given. So being able to identify what equation you need for this problem. Rearrange. So the way that this equation is written, I can't solve for anything specifically. So eventually we're going to work on maybe saying, what is temperature? How do we rearrange this? And then we're going to substitute and solve. So that would be, let's say if I need temperature in degrees Celsius, but I only give you degrees Fahrenheit. How do we do that? So rearranging then. Evaluate. This is my favorite. So evaluate is being able to say, okay, I plugged everything in. I got this answer. Does it make sense? So let's say I looked for a temperature, but the temperature was like 20,000 degrees. Does that make sense? If, I don't know, if 20,000 degrees Celsius. So like, if it just doesn't make sense, that's what the evaluation is. So don't just answer it because you're rushed or you're trying to get the answer out. Does it make sense? That's what the evaluate is going to be. We're going to hit dimensional analysis next class. Dimensional analysis is, being able to convert one thing to another. It looks a little complicated in high school or before. You might have seen like railroad tracks being used where like it's the same thing if I put the 40 over here. I'm going to try not to use the railroad tracks because it's just hiding the fact that I'm multiplying fractions. So this is something that always catches students. So this is just multiplying fractions and how are we going to do it? Going from one thing to another. If you're confused where these letters and numbers are coming from, I'm just going to put up glucose. Glucose is C6H12O6. That's a 12, not a 2. Okay. So C6H12O2. If I had 40 atoms of carbon, how many atoms of hydrogen would be produced? So dimensional analysis is how we go from one thing to another. And we're going to cover this next class. So we're going to be able to look at this molecule and say, there are 6 carbons for every 12 hydrogens. And if I ask for oxygen, for every 6 oxygen. So I can write this as 6 carbon equals 12 hydrogen. It's the same thing as 6 oxygen. I know Dr. Patterson had a really good one. She says it's the same thing as if I'm talking about a car. I have 1 steering wheel for every 4 cars. This is the same thing. So looking at this molecule, I have 6 carbon for 12 hydrogen. So if I need to go from carbon to hydrogen, I would have to use that concept. Okay. This is the last slide. This is just our goals. So we are going to be trying to implement knowledge and skills. So knowledge comes with little steps. So every day or every time you're working on this class, you're taking little small steps to learn something, but it builds. And so after maybe a month, your knowledge is growing by too much. So it takes those little steps. Those small steps are coming to class, doing the practice exercises, and doing your homework, things like that. So the small steps. Your skills, we're going to be developing very important skills in this class, and that's going to be practice. Just practice, practice, practice. Those skill sets are going to be very beneficial later on. So even though this class is not required for you to be here every single time, please do your best to attend. And if you can't attend, I will be posting our online lectures on our Canvas calendar. So that way you're never, ever going to be behind. With that in mind, sometimes I do get emails from students saying, I missed, what do we do? I'll just probably just say, what does the Canvas calendar say? So go there first. Any questions on that? That's unit 1.1. We just finished that. Hey. And I'm gonna switch to the next one. We're gonna move on to combustion. That's a much better picture of combustion. So when I think combustion, I do think explosions. So here's just a really good picture of what a combustion reaction would look like. What do we already know about combustion? So I'd love it if y'all could blurt your answers out or type, when you think of a combustion reaction. So go ahead. Yes, so meaning oxygen. Heat. Anything else? You could also like tell me like what is a combustion or like examples of?
Light exhaust,
Say it again.
light exhaust.
Light, yes, light and heat are produced. Fire, yes, and these s'mores are right here, making me hungry for lunch. Let me make sure.
Require some kind of fuel source.
Fuel, yes, it needs to have something that can be ignited or combined with oxygen to produce something, so a fuel. Sometimes when I think combustion, I think of like fireworks or turning my stove on if I have a gas stove. Lighting a fire, things like that. So these are all really, really good examples. And you're thinking chemically, like so beyond what it actually is, like chemically, what is going on. So macroscopically, what does it look like? Microscopically, y'all mentioned oxygen, heat, light, that's microscopically. Yeah, so I have on the next slide some demos. Oh, we have one more minute till we have a break, but if you are gonna watch these at a later time, I'm just gonna recommend turning off the try to like watch it on mute first and then watch it with the volume later, just so you can kind of think about macroscopically, microscopically, and things like that. My alarm's just about to go off, so like after the break, we're gonna come and watch the videos. So I guess I'll start our break 1 minute early. So 12:55, we'll come back. So you can I would recommend stretching, going outside, get some sunlight on your face, or just, get your blood flowing again, so.
Battery.
That's something these days.
Oh,
Pretty good.
started at 100, I'm at 24%.
Oh, gosh.
This thing is like 6 years old though.
Oh. Maybe more. Yeah. So many things. But I can't use the touchpad. Like, you really need that, like, yeah, it's about right. It's a compliment. I don't have any service. So I was gonna do that next day. I was like, oh, look, it's not in my backpack, fine.
How great is that?
Jeez, we don't like these chairs. So you're saying for linking the book to your Canvas?
Only one of them. The bottom link, go through the bottom
Okay.
link.
So I found that you're saying there's a way to link it to where you can just.
I think you go through Canvas Gradebook. Yeah. I have all these.
How do you do it? Okay.
That's
so
what I did to
In
confirm.
Canvas, it's just gonna, you just like gotta open another tab.
Yeah.
Oh, okay, alright, just. Cool. Thank you.
Sure, there might be one you might go check out. Or like the, I think so. Is there like a bookstore? If you go to like the bookstore, you'll see like the ISBN, and you can go to library. I just don't have to pay for it, so I think the book, renting it from the library would be the best way. That is subjective.
Yeah.
I am an analytical chemist. I don't like organic, but a lot of people don't like analytical. So it's just, you gotta find your niche. I love math and not everyone likes math. So
Really like organic. What do you?
physical chem, I think, is what we're doing.
I watched him struggle with that one and I was like, that is a fun child with the racing industry and it shouldn't exist.
It took me a few tries to get it, but when I finally get it, I'm like, oh, it's not so bad.
Struggle.
Two different guys.
This is the man who like just.
Oh, I'm jealous of those. That was never me.
I say that now, but I'm fine.
See, it's subjective. Someone might look at that and be like, that's awful. Because I always hated it when I was in LSUs and like people like, what's your major? And I'm like, chemistry. Or I think if my major is biochemistry, and they're like, oh, I'm like, I love it. Why are you shitting on my major?
I was like, I started as engineering and then so many people made me so scared of Cal too. And like I did it and I did it. And I was like, are you really good?
It's harder, but it's
This
not
is
impossible.
hard.
Yeah. Well, I thought it was hard, but it's not like impossible.
I didn't think it was that fun. And so then I took Cal 3 for funsies and I actually really liked it. So now I'm over here about taking analysis. So
You found your niche. And applied has a lot of good application. There are a lot of careers. Materials is hard, yeah.
here we be. I'm kind of scared to take.
It was kind of like a mix of conceptual and math. But like this course, if some students like,
There's some things we worked on and differentiate major.
yeah,
Let's see how like.
yeah, and this course can be like, if you don't have like a chemistry background, like I know I went to a high school with not a good chemistry and programs, so I desperately needed something like this. But like some students will take this course and be like, why am I taking this course? So there's gonna be a giant, like, it depends on where people are coming from and the background, and it's,
I did have a campus one, but as the chemistry department, 16 years ago, and I was classmates.
no,
I
really.
was like, that's fair.
Okay, let's get started again. I'm gonna play these movies on mute because we're gonna try to think of this microscopically, and not symbolic, of course, but we're gonna try to think about what's going on. So this is a methane bubble. I want to point out methane is just CH4, so it's carbon and hydrogens. And that was that symbolic, reaction I had on one of the first slides. It is methane in that pipe. Sorry, I know it's boring without the sound. Okay, so we're looking at infrared. Okay, so he has methane trapped in those bubbles. I love the infrared. Because we saw it in two different parts. We saw the heat that came off of it and we saw what it actually looks like. So methane is a fuel, right? It was in those bubbles and he put it in soap to get the bubbles and then he lit it on fire. What did the thermal imaging, what was the main part of having the thermal imaging? Obviously, we're not in the room with him, so there's no way for us to actually feel the heat coming off of it. So it's really cool to see that, see it as a video, to see that, this combustion produces heat and light. Let's go to the next one. This one is an exploding hydrogen balloon. Hydrogen is a gas. It's not going to be pure in what we breathe. But if you have a balloon with pure hydrogen, what happens when you try to light it? So think about it. I'll probably rewatch this afterwards with sound to see what it sounds like. Also, don't ever do this at home. I wouldn't even do this at home. Yeah. So what did you see? What was the size of it? Like, was it bigger than the balloon, smaller than the balloon?
It's a little bigger.
Okay. So let's think about it. Here's another one. Like the gas is so big. Can anyone tell me why when they lit it up, the explosion had to get bigger than the balloon? What's required for an explosion? Think of the two elements, right? If I fill up a balloon with just hydrogen, can hydrogen light on fire? No. So it's trying really hard to find that oxygen to light on fire. So hydrogen is flammable in that same reason where it's going to try to find oxygen and instantly going to ignite. But that's a great perspective of size. Also, this is why if you are on oxygen, you're never supposed to smoke, because if you have pure oxygen near you, it'll ignite, and a lot of people have died from charring their lungs. Don't do that. Do y'all know about that balloon? I forget the word, the balloon that had that big explosion in the 30s. Do y'all know What I'm talking about? Yeah, the Hindenburg disaster. Does anyone know why it was so bad? They filled the balloon with hydrogen and not something like helium or something else. But it is very flammable because it's gonna have a massive explosion when the combustion's looking to react with oxygen. So that's why that disaster was so bad. They filled it with helium. All right, here's another one. So he's going to try to light a match in a bag full of hydrogen. But it's a closed system. Ooh, I love that color. Why is it instantly going out? Yeah, you are on it. Yeah, there's no oxygen. So when that balloon was in a system, an open system, it was able to go find oxygen. That's why the explosion was so bad. But in a closed system where there's zero amount of oxygen, it was able to ignite it because that sulfur does have a little bit of flammability, but it couldn't burn because there's no oxygen. So a combustion reaction requires oxygen. And this one's is a fun one that's out in left field a little bit. If I can get it. So this one is burning magnesium. So magnesium is a metal that is pretty flammable. So he's gonna burn it and it's gonna produce something. So that's just a magnesium strip of metal. It's very malleable. Yes, definitely be safe. I wish we still did stuff like this. This is actually a lab that I've done in general chemistry at North Texas, where you create whatever what he's about to show you. At least I hope. I guess I don't zoom into it. He had the equation on the board behind him. Pause that. So magnesium, pure magnesium plus pure oxygen combine to create something called magnesium oxide. So previously, in the combustion reactions, it was producing carbon dioxide gas and water as a vapor. This is a different type of reaction where you're taking a metal, which is magnesium, and of course oxygen, and it's no longer going to produce those gases. And instead, it produces a powder magnesium oxide. And we have some more slides where I kind of zoom in that on a micro level. But what I want you to think on the macro level is like if I just had like soot, gray soot, that would be like magnesium oxide. So it's just a different type of combustion reaction. I can't really use the word combustion for it, but it's a different chemical reaction with flames. That's not quite combustion because it's not producing that carbon dioxide and water. Right. I love these types of videos. There's a lot out there if you want to like just watch people do chemical things. I'm sorry, I'm like unable to do both. Two computers. Back to the combustion slot. Nice little delay. Yeah, so if you want to go watch this afterwards, watch them on mute. You can definitely go watch them on volume. Those hydrogen balloons are gonna be very, very loud. I don't know how loud the room is, so I kind of made the decision not to, because these rooms can be pretty loud when they blare music. It's very, very loud. All right. So how do chemists represent all of this? So when you are, I guess, sometimes I don't even feel like I'm a professional, but when you get further and further on into chemistry and you know, maybe make a career out of it, you're thinking of all of those different things. You're thinking about what are you seeing with your eyes, what's happening on a particle level, and, you know, of course, lastly, symbolically. I feel like majority of the time we're dealing with symbolic level, but we're forgetting about how much fun chemistry visually is. And so we're gonna be trying to think about all three of those things as the semester goes on. Maybe I can bring in some more simulations like that to kind of show things. Yeah. So we've been hinting at the periodic table of elements, but it all goes back to Dalton's atomic theory. Elements are made of tiny, indivisible particles called atoms. Atoms are just what we kind of use to represent each individual element. So atom sizes and atom other things like that. Just note that when I say atom, it's just kind of being identified as some type of element. The atoms of each element are unique. So one atom of, let's say, gold is very different than one atom of carbon. One, they're very, very different in price. Yeah, the color, the weight, everything else about it, they're very, very, very different. But you can say, you know, an atom's an atom. So, you know, atom is all represented these elements. I did pass out those periodic table. So I'd love for you to get out that periodic table of element table or that with you so we can maybe mark it up. Atoms can join together. So sometimes there is something causing atoms to come together because not everything wants to be by itself. Some things are very, very happy by itself, like metals. If I was to have just gold, it'd be very happy by itself. But some things are not always going to be as happy. So if you look on the left here, red is going to be something you're going to see very common. This red circle is just going to be represented by oxygen. Black is carbon. And hydrogen, which is really small, is white. So these are ones that typically don't want to be by themselves, with the exception of like graphite. Graphite, if you make it, you have to do certain things to it to make it by itself, but typically carbon wants to be attached to something. Inside, I would love us to kind of identify what are these compounds. Okay. So let's look in the top left. So we have two reds connected to one black. What is that? Carbon dioxide. So I have C and I have two. And so I will write it as CO2. The reason why I don't write O2C, even though it would be correct, is typically what we'll do is we'll put the central atom out front. So you'll see that trend with the exception of water. Water is the only one that doesn't agree with that, which I have right here. So I have one oxygen and two hydrogen. The subscript that follows it lets you know how many are attached. What about in the bottom left? Methane, yeah. You already know that's methane. Methane is CH4. So I have one carbon and 4 hydrogen. And then what's the last one? Just oxygen. So I don't have to say like dioxygen or anything like that. It's just oxygen. O2. Oxygen does not want to be by itself. So it's one of those things that we write as diatoms, meaning that it just connects. So O2, that's where oxygen's going to be happy. And it's gas. So let's talk about particles. We're right now talking micro scale because we have the atoms in front of us. If you read your book, we talked about atoms. What are atoms? What are compounds? What are molecules? Mixtures and things like that. So on the left, we have atoms. Once again, black is carbon, red is oxygen, white is hydrogen. And typically we are going to say the bottom one's a metal. I might assign it as something. I think I'm going to assign it as magnesium later on, but we can just say metal, just generic. There's just not enough colors for all the elements. So if we have them, just not enough. So metal. So we kind of did all of these. These are what happens when two atoms just want to be connected to something else, and that is what we call molecules. I do want to point out there is a trend here. Are carbon, hydrogen, and oxygen, are those metals? No. How do you know they're not metals? It's okay. Sometimes we just know, right? We've been taught in our own lives, but I didn't know why they're not metals. Yes, and that's what we're gonna get to. We're gonna learn about the periodic table and what are metals and what are metals. So I note that these are molecules because they are all nonmetals. So if a non-metal attaches itself to another sorry, terrible handwriting. That would make a molecule. So non-metal plus non-metal. On the right, we have a metal plus a non-metal. It doesn't make the same exact bonds as the molecules. The bonds are slightly different. So we have, this is something that we have formula units. If I wanted to like get into specifics, let's say this is magnesium. Let's say this is magnesium and oxygen. How many magnesiums are here? 8. How many oxygens are here? So the word formula unit is the most simplest version of this. We can't do this for the other ones. So I can't do this for O2. I can't say O2 is equal to O. It's not the same because those bonds are different. But for ionic bonds, this is what a metal plus a non-metal. We can simplify. So if I was to simplify this and get it into its lowest value, what would it be? It would be 1, right? But typically we don't write out ones. We kind of assume if I was to have Mg1 and O1, that would be the same thing as MgO. So the formula unit is the most simplest version of that. So this is the formula unit, so MgO, even though it's Mg8O8. Okay. And once again, ionic bonds are metal plus non-metal. Let's continue in molecular. What they did here was in the bottom, I don't know why it's missing its little, it has these little fun little things it's missing. On the bottom, that's the symbolic representation of this reaction, but on the top represents the microscopic representation. So we have CH4 plus 2O2. The number out front just represents how many of them. Can anyone tell me why I can't just say this is O4? They're not connected, right? So because they're not connected, I can't just cram them all together and say O4. That just wouldn't be correct. So there's 2 of them, there's 2 O2. I don't know why it's not letting me write. There it goes. All right, and their arrow just represents the 2 combined, the reaction happened, what is the product? So the product, we have 1 CO2. I don't write it because it's assumed. If it's by itself, it's a 1. And then I have 2 H2O. If I was to play around and use different fuels, the numbers will definitely change, but here's just a micro versus a symbolic version of this combustion reaction. I kind of hinted at this before, but this right here is the formula for H2O. We don't typically like break things up. I don't add things to it. We just play around with the number out front to represent if there's more or less of them. So if it's a formula and it's set and those are those bonds, we don't play around with it. So I wouldn't say this is H4O2. That's a completely different compound. So it has to be 2H2O. And then the equation is the whole thing. So all of it is the chemical equation or the chemical reaction. And then inside of it are those individual chemical formulas. I do want to point out there is a law of conservation of mass, which means that whatever you have on the left has to match what's on the right in the way of the amounts. If I have 1 carbon on the left, I also have 1 carbon on the right. I'm not gonna lose or gain or make up or have new things introduced. Like I would have to incorporate that if it did happen. So law of conservation of mass. If you have a carbon, you have to have a carbon on both sides. So if you were to add things up, you have the same amount of oxygens on both sides, same amount of hydrogens on both sides. So every atom on the reactant side, you'll hear me say this from time and time. Left-hand side are the reactants, because that's what you're combining to create something. The right-hand side are products, meaning that I created something new. Those are the product of this chemical reaction. So every atom on the reactant or left-hand side is accounted for on the product side, even if it is a different compound altogether. Dr. Patterson loves Legos. So she says, just think about, using it as Legos. I'm taking apart, putting them together. So on the left-hand side, this whole reaction is coming apart to create something new. You'll see something similar, subscripts. So subscripts are those little small numbers we put at the end of those letters, and that just represents how much is attached to it. So you have CH4. The 4 is not big because that 4, if it was big, would represent something else. So we're saying that that lowercase 4 after the hydrogen means there are 4 hydrogens. If there's no number after it, assume a 1. Okay. Same thing here. We don't say this is H6O3 because 1, they're not attached. They're not connected. It will be a completely different compound. There are 3 separate H2Os. So subscripts are what's behind the element. Coefficients are what is in front. So if I was to have a 1CH4, that's the same thing as having no number out front. So the coefficient, regardless if there's no number, is still 1. So coefficients out front. It just lets you know how many of them are there. And then just a reminder, H2O is weird. It's the exception of the rule, but typically the central atom is going to be what goes out front. Now let's work together here. They've assigned the colors and the elements. Let's go ahead. Actually, I'll let you go real quick. So in your notes, I'll give you a minute. Write down what you think each of these are, and then we'll work through it together. Oh, just got news. Our new classroom is going to be GO2. So it's going to be next to the original one. I'm so sorry. I'll make an announcement later. Yeah, sorry. While we're in break, I was like emailing them like, come on, fix this now. All right, let's start with this top left one. What do you think it is? So this one would be, aren't you doing this? NH3. So there are 3 hydrogens connected to a nitrogen. Why is it not H3N? Because the nitrogen's in the middle. I like different colors. Okay, what about the one next to it with the red and the blue? N2O4. Yes, because the nitrogens are in the middle, we're going to put them out front. All right, now the next one's going to have a coefficient. What coefficient? 5 what? I bet my battery is just going out. Yeah, battery. So 5H2O. There should be a space in between them. I didn't write one well. So 5. Okay. What about this last one? Cl. So similar to O2. This is chlorine. Chlorine does not want to be by itself. It wants to attach to anything it's around. And if there's multiple chlorines, it'll attach to itself. So Cl2 is, you're never going to see Cl by itself. Okay. But yeah, that's how we write formulas if I was to give you those particles. And you'll get more and more comfortable recognizing if I was to just take out the picture itself, you'll start to be able to visualize what's going on. Right in this one, we want to kind of recognize a pattern here. So I want to let's just focus on the right-hand side. What's common between the two products? Huh? Yeah, so so you have, yes. The water is definitely produced, always gonna have in a combustion reaction. But between the CO2 and the O2, sorry, in the H2O, my bad. They both have oxygen. So that's just a common thing. Look, we're just recognizing patterns. What are we seeing? So what I want to point out is in these types of reactions, you're going to kind of see these flip-flop and kind of move and attach each other. So when a combustion happens, it's not really going to be able to kind of go, I'm jumping a couple steps. It explodes, right? So I can't have anything of what I had before. So whatever I had before is no longer there. When it explodes, what happens is the more comfortable, easier things to happen are going to be CO2 and H2O. So the hydrogens will attach to each of those oxygens, and of course, each of these oxygens will attach to those. That's kind of like splits itself up, and then it just rearranges itself to a better energetic reaction. So yeah, I just want to point out what is happening here. So our reactants break apart in that explosion, and then it comes together in the products. Right, let's go back to that previous one, the magnesium oxide. So remember that magnesium is a metal. And oxygen is a nonmetal, which makes an ionic bond. So these bond differently than the other one. So it won't make a covalent bond, it'll make ionic bond. And in this case, it looks similar to this. That is that magnesium oxide powder, that gray powder I was pointing out to you. So in this one, I would not write it as M808 like we previously discussed, because with ionic bonds, we try to come up with the simplest form of it. So that would be, I'm missing a G, sorry. So this would just be MgO. So the simplest formula unit. Some questions to ponder. Why are the properties of magnesium oxide so different than the properties of water and carbon dioxide? Let's think about when I say structure. So magnesium oxide, when it's a powder, is that a solid, liquid, or gas? So it's in solid form. Carbon dioxide and water in an explosion are going to be in liquid form. So one, their phases are completely different. So that kind of tells you a lot about what's going on between the connections. So those bonds are going to be a big reason why their structures are so different. So once again, you have ionic bonding. And then this one's going to be covalent. Okay. And that's going to be why the reactants are so vastly different. Let's talk about the differences between them, and you will need your periodic table of elements to help this in a little bit. So electrons are transferred from metal atoms to non-metal for ionic bonds. So you need a metal and a non-metal, and it's going to be very important to identify those with this. Ions are held together by attraction of opposite charges. And then they have the extended 3D crystal structure, which is what we have above. That's what it visually looks like when you have a bunch of ionic bonds. Covalent bonds are going to be happening between a non-metal and a metal. So atoms are held together by attraction between them and a shared electron. We'll get into more in depth of that later. And these are what we call molecules. Molecules will have covalent bonding from non-metal to metal. I'm so sorry. These are also going to be solids, liquids, and gases, where ionic compounds are always going to be solids, with the exception is if you mix it with water. But ionic by itself is going to be a solid. Let us get our periodic table of elements out. It's going to be very important for us to identify on this table where are the metals and the non-metals. And I like to use this gray, the grayed out areas. Let's see, I've never used this. Everything to the right of the grayed out portion are non-metals. The grayed out portion is what we call metalloids. They act as a little bit of both, but they're not a non-metal and they're not a metal. They're in between. Everything else is going to be a metal. So that's really helpful. So I recommend trying to figure out if it's a metal or not. It's like, is it one of these little few ones? And if it's not, it's a metal. So definitely on your periodic table elements, say like, what's the non-metal? You see it. Yeah. Oh, shoot. And then that's gonna be very important to be able to identify. So here is everything in white is a metal. Everything in gray is a metalloid. And everything in yellow is a non-metal. So what I'm gonna do is I'm gonna erase this because I still wanna talk to you about what other identities are, but definitely identify or make a note to yourself on your periodic table of elements, what is what. So I'm gonna erase this because we're now gonna identify what are the columns, some more identifying things. Does anyone know what this first column is? No worries if you don't. I just don't even have to memorize myself, but have you heard of alkali? Because I hear that a lot with like some companies are saying, I have alkali water for you. It's like you don't really want that. So, but yes, the first column is what we call alkali metals. So hydrogen is not a metal. It typically is top of column 1 because it acts like a metal in certain cases, but it is not a metal. Hydrogen is very much over here. So when I'm talking metal versus non-metal, never assume hydrogen's a metal. But column 1 is alkali metals. Does anyone know what I mean by I say column 1? So kind of treat it as rows and columns. So you have rows that go across, columns go down. So all of column is going to be an alkali metal. Column 2. Does anyone know on top of their head? No worries, I don't even have it memorized myself. It's what we call alkaline earth metals. Or alkaline earth, but I always will just write alkaline. Just more important to recognize they are metals. They may act differently than what we consider a metal as in like iron. Iron's definitely a metal, right? So everything in here is what we call transition metals, because those are our more typical when I think of metal. Silver, gold, cobalt, iron, all of that's going to be in here, and those are transition metals. I'll put a little bracket to let you know it's all of that. So columns 3 through, I think, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, column 12, 3 through 12 are transition metals. And then this last column, these are what we call noble gases. Not the OG in the bottom, all the red ones. these are very happy by themselves. They are in the gaseous form, like things like neon and argon. They're just very, very happy existing by themselves. So we call them noble gas because they're happy being by themselves. Columns, the second to last column, I don't know, I'm running out of room and I apologize, are what we call halogens. Let me just write it down here. Halogens. 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 And then the second or the third to last column is what we call chalcogens. 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 Let's go back. Chalcogens. Now, I don't expect you to have those memorized, but we are going to play around on the next slide and practice utilizing them. Okay. So hopefully everyone has the metals labeled, chalcogens, halogens, noble gases, and then of course knowing everything's at. Now, if it's not labeled, so for instance, we did not label these, just don't put anything near them. We don't really have that special label. I want you to know nothing. So we did all this. And let's practice right now. So I'll give you some time. So our goal is first identify, is it a metal? Is it a non-metal or a metalloid? So if you don't periodic table, but a balance in front of you, go to the slide before. But go ahead and just let's do the first one. Sulfur. If I look over there, sulfur is going to be A. All the way to the right, third to last column. Non-metal. So I'm going to put non-metal next to sulfur. And it is in the chalcogen column. All right, so you'll do something like that for the rest of them. So identify metal, metalloid. I know with the metals, there's so many, so give yourself some patience trying to find them. First, I would look in the metalloids. There's so few of them that if it's not a metalloid, it's going to be one of the others. Ooh, that's a great suggestion, getting the periodic table at chemistry. That is, I might do it to myself. I always need a periodic table of elements. Thank you. That right now. let's go down real quick. It's okay if you haven't finished, just because I only have 4 minutes left and I want to definitely get to the next slide too. We'll do alkanes next class. So we'll do that activity. Please don't misplace it. I'll bring extra copies just in case, but we'll do that next class. And you're always welcome to get ahead. Never gonna stop you from doing that. TE.
No.
Wait. I had a very hard time finding it until I was like, let me look at the metalloids. Does it have a name? No, what I meant was, remember how I said like is alkali, is a transition? Chalcogen? Perfect. Alright. PO. Now. FE. Metal. LI. First column. F. The halogen. BA. There's a moth up here. And carbon. Non-metal. Does it have a name? I didn't give you one, so no worries. Perfect. So like I said, it's perfectly okay if you weren't able to finish it. But it's just a really fun challenge to be able to like, okay, are we comfortable with the periodic table of elements? Can we label it? The more you see it, the less it's memorization. That's how I feel. Like the more I do it, the less I feel like I have to have it memorized because it just comes back to me every time I try to relocate it. The last slide is we are now going to go through and identify, is it covalent, meaning non-metal and non-metal, or is it ionic? So I'll write down the little tips and tricks. So ionic, or metal plus non-metal. Or is it covalent? And if you have to head out when we have 1 more minute left, so no worries if you have another class, but I'll go through the answers if you want to stay. And then please bring your periodic table elements to class every day. That's the end of class. You want to go through it real quick? All right, number 1. Covalent. I'll just do C and I. C. What about number 2? Yes, lithium is a metal, which means it has to be. None of these are metal. 3. Covalent, non-metal plus non-metal. Number 4. Ionic. And then number 5. Covalent, yes. Okay, so we finished combustion, that first one. We will start alkanes next class, do the alkanes activity, and then we will do dimensional analysis after that. So great job. So sorry for the hectic day. I'll email you about the new classroom, but if you prefer online, that's always an option too. So great job, everyone. I'll post this after class.